going to prove a theorem regarding absolute values. It can get you out of jam sometimes. And the theorem goes like this. If x is in between negative a, and then, okay, then, of course, a and c, which I'm about to write, are real numbers, then negative a times the absolute value of b is less than b times x, which is less than a times the absolute value of b. Proof. Now, notice that I maintain that this is negative and that this is positive. Now, let's just think about what's going on. Here's negative a, here's positive a, and x can be in between here. Okay? So, negative a is less than x, which is less than a. Now, suppose b is negative 2. So, negative 2 times x, I claim, is in between here. That is, negative 2x is in between negative 2a and a. Now, this makes sense because here's 2a and here's negative 2a, and x is anywhere in here. Well, if I multiply by 2, or multiply a positive number by 2, I will get less than 2a. Because actually, it doesn't say x can equal a. It says x is, and if I double 0, I'm going to get here anyways. And if I double any of these numbers in here, you have less than $8, and somehow it gets doubled, you'll have less than 2. You will be less than 2a. Same argument here. If x is negative, and you multiply it by, if x is negative a, you multiply it by 2, well, I mean, actually x is less than negative a. If you multiply negative a by 2, you'd end up here. If you multiply smaller numbers, you'll end up in here. Okay. And I've gotten out of a lot of jams on proofs using this. Very helpful. Okay, so let us see how we can do this. Well, I guess I'll do it by cases. If b is 0, so let me say that. If b is 0, that implies the absolute value of 0, absolute value of b is 0. And it's really true because negative a times 0 is 0, and 0 times b is 0, and a times 0 is 0. So that one works. Case 1, b is 0. And just 2 more cases. Case 2, b is positive. Okay, and this is the easier case. This is the easier case because what does this become? Well, if b is positive, well then this is a times b, and this is a times b. Well, yeah, I mean, if you initially had this, and then you come and you multiply all sides by a positive number, there's no problem. Yes, no problem. Absolutely no problem. So now, let's look at case 3 where where B is less than 0. Case 3. B is less than 0, which implies that the absolute value of B is negative B. So what we have is that X is in between negative A and positive A. Now, if I multiply all sides by B, which is negative, I'll get negative A times B is greater than X times B, which is greater than A times B. Or, reversing the order, AB is less than XB is less than negative AB. So, what I want to show is that XB is in between A times the absolute value of B, which is less than which is less than A times the absolute value of B. But remember, the absolute value of B is negative B. Okay. So, we have this. Ooh, XB is less than. Now, this here is the same as A times negative B. Well, here's A, but negative B, the absolute value of B. And this is, well, this right now, there is no sign. So we'll assume it's positive. So this is the same as negative A times negative B. Well, negative A is negative A, and negative B, oh, that's the absolute value of B, and I got what I want. Okay, again, if you have negative A is less than X is less than A, you could multiply the middle by any number you want, including a negative number, as long as you put the absolute values on the outer ones. This is still true. I know it is. I proved it. Okay, so if you know that X is in between negative 4 and 4, and you choose to multiply both sides by negative 7, if you choose to multiply the middle by negative 7, you can easily maintain those equality signs, inequality signs, as long as on the outside you multiply by the absolute value of 7. And this saying that if X is in between here, then negative X is guaranteed, remember this is 7, and that's 7, is guaranteed to be between negative 28 and positive 28. If you know that X is in between there, you multiply by 7, that is negative 7. You can now say that negative 7x is in between here. So basically what happened is, if you know that x is between these two numbers, and you multiply the middle by negative 7, you can multiply the outsides by 7. You can multiply that outside